Hello, everyone. Welcome to Huawei AIoT Online Training Camp. In this chapter, I'll show you how to use an AI model to predict goods sales in a region. After learning this chapter, you will be able to use Model Arts, a one-stop development platform on Huawei Cloud, to migrate data, pre-process data, build neural network models, train models, evaluate models, save models, and apply models in practice. These operations are also the basic process of AI development. I hope that you can learn these key steps through this chapter, according to the basic procedure of AI project development. This chapter is divided into 6 sections. Now, let's look at the first section, collecting vending machine data. This section describes how to convert the data format from JSON to CSV, understand the meaning of vending machine data, and explore the value of data. Data format conversion involves 3 steps. First, upload the jar data generated by the development board to OBS on Huawei Cloud. Then data is stored in OBS, which is convenient for us to use Model Arts for data pre-processing and model training. Second, create a notebook on Model Arts. A notebook is a development environment, which can read data in OBS. Third, merge all data in the JSON format and convert JSON files to CSV files. Then, save the files after conversion. CSV files are more readable and intuitive for the model to parse the information contained in the data. From the data, we get about 16 million samples and 33 fields of information, including the order ID, area, device, latitude, longitude, region, order time, order status, purchase quantity, total price, payment method, product type, unit price, user ID, and user age. Based on the preliminary understanding of the data, we can see that most of the data is numeric. We need to further check the data type to see whether operations can be performed. Some data is object type. Then, convert the data from the object type to the float type, so that the data can be used to train the model and run algorithms. In this section, we use several important functions to implement the code. First, merge JSON files. We define a function to merge all the jar type data. Specify the path of the jar package data in the main function and the path of the output data in the function body. Open the target path. Then, read the data step by step. Write the obtained data to the target file. Close and save the file after the data writing is complete. Next, convert the time format. Convert the timestamp to the standard time format. First, use the local time function in the time package to convert the time in the data to a timestamp. Then, use the strif time in the time package to convert the timestamp to the format that we need: year, month, and date. To delete some unwanted columns, we use the drop function. For example, if we want to delete the column named event time, write the column name first. Set the axis parameter to 1, indicating that the deleted data is indexed by the column name. The last step is to save the file in the CSV format. Use the data underline new to underline function and specify the target file path in the function body. On this page, I'll further explain the code. First, we need to convert the data format. Before the conversion, we need to import the required data packages, such as pandas, numpy, and os. Then, use the merge JSON function to merge the JSON files. Next, we use the read JSON function in pandas to read the JSON data, and use the head function to query the first 5 lines of the data, so that the data in the JSON format can be parsed from line to line. After the data is parsed, change the timestamp to the required time format. To facilitate the extraction of area information, we extract the area information from the device field and generate a new field district. In the jar package data, the default columns defined by the development board are meaningless. We can use the drop function to delete these columns, and then save the data after the deletion in the CSV format. After obtaining the data in the CSV format, use the shape function to query the data shape. Use the types function to query the field type of each column. If you want to change the data type, use the asType function. Convert the columns in the numeric type to the float type, so that we can use the data to run algorithms later. After the conversion, you can use the types function to check whether the data types are converted successfully. Finally, let's run the code and check the result. First, visit the official website of HOV Cloud. Enter an account and the password. You can alternatively click I am user login and log into the management console as an IAM user. After logging into the management console, search the OBS service. And find your bucket. Just open it and find which file used to save your data. Open it and create a new folder named model. And then upload our Jupyter notebooks we gave to you. Or you can create a new one in Model Arts after you finish it. Your objects like this. Then search the Model Arts service. Click Try Now. And then make sure the area is Beijing 4. In the notebook list, click the DEV environment. Find and open the notebook that we are using for this experiment. And click Start. We should wait a few moments. And open it. You open the Jupyter. Select all folders in the notebook. And then click Sync OBS to synchronize all our files with data in OBS. Now, we can start compiling and running the code to get the experiment results. By the way, we should make sure our environment is TensorFlow 1.13. When we run codes or comments in a window, we should click the left area of the window and press Shift and Enter button to run it. Just like this. That's all about the experiment, but we leave 2 questions for you to review and think further. In this experiment, what is the format of the data we get from the development board? JSON, CSV, Excel, or XML? The answer is A. JSON. The format of data that we uploaded to OBS on HOV Cloud is also in the JSON format. Then, we parsed the JSON data and saved the data in the CSV format. Now, let's move on to the next question. Which of the following statements about functions are correct? The open function can open a specific file. This answer is correct. The drop function can delete a specific column in the data frame. This answer is correct. The toCSV function can convert other formats to the CSV format. This answer is also correct. The last answer is correct as well, because the shape function can be used to query the data shape. Therefore, the answer to this question is ABCD. Through the review of the 2 questions, we have reached the end of this section. In this section, we talked about how to prepare data and convert data in the JSON format to the CSV format. Also, we talked about the meanings of some data and how to convert data types. This section lays foundation for the next section about data preprocessing. This is the end of the section about preparing data. Thank you for watching. See you next time.